The next video builds a good analogy to aid in understanding electrical potential. It shows electricity as a potential difference, just like an elevation difference in a gravity field. The lower the voltage of the charge, the lower the potential energy of that charge. The height of a picture on a wall is different when measured relative to the floor versus being measured relative to a countertop. These two measures represent different amounts of potential energy. In the same way, measuring voltage requires a 0-volt reference. That reference is called ground or neutral, and one multimeter lead must be connected to the reference. You can't measure a voltage by touching only one probe of a multimeter to what you want to measure. That does not work because voltage is an electrical potential difference. Using only one probe is like taking a tape measure and just putting it beside a picture on a wall. The end of the tape measure has to go down and touch the surface of the countertop or floor or some other reference. The ceiling could be used as a reference. The important thing is that a reference is selected and known. So heights could be positive or negative. In the same way, electrical potential can be positive or negative. The potential at a point in a circuit could be above or below whatever reference is employed. That's why AC current varies as it does. The hot wire is at a different electrical potential than the reference, which is neutral or ground. So the hot wire will go above the reference and below the reference. It is important to understand this so that when you use a multimeter, you understand that both leads must be used to measure voltage differences. Measuring current is different from measuring voltage, though it also requires the use of both probes. When measuring current, the circuit must be interrupted. There is always connection from the power source and back to it in every electrical system. So when you need to measure current flowing through a circuit, you have to actually put the meter in line with the circuit. The meter can't just be in parallel with the circuit as it is when measuring voltage. The meter has to become part of the circuit so that the meter carries whatever current flows in the circuit. If the meter doesn't have the capacity to carry the full current pulled by the circuit, the meter can fail. Usually a fuse is included in the multimeter so that when too much current flows through it, the fuse fails before the current damages the multimeter. But the most important idea in the next video is that voltage is a potential difference.